Right. In this part of the lesson, I want to make the distinction that now we're going to use the critical numbers to find out or determine the absolute minimum and absolute maximum on a closed interval. So we're actually going to look at specifically closed intervals right now, and those intervals are guaranteed to have both an absolute maximum and an absolute minimum. But in order to find those, we'll need to know the critical numbers. So you have these three guidelines. First of all, find your critical numbers. You're going to do your derivative, set it equal to 0, or also finding out where it might be undefined. And then we will evaluate your original function at the two endpoints of the closed interval, as well as at each critical number. And then your least y value will be the absolute minimum, and your greatest y value will be the absolute maximum. So I'm going to give myself plenty of space to do this work. So we'll start with number 5, and I have just a simple polynomial for us. F of x equals x to the third minus 3x squared. And my closed interval that we'll look at is from -1 to 3. So first step, I want to try to number it so you can follow the guidelines that were listed above. You will do your derivative. So f prime of x would equal 3x to the second minus 6x. And then we'll look to see where our f prime of x is equal to 0. We already know, since it's not a fraction, that f prime of x undefined is not going to be a situation with this one. So we won't have any critical numbers from that, but we can find where f prime of x is equal to 0. So 3x squared minus 6x equaling 0. Little reminder on your algebra, you cannot add 6x and then divide both sides by 3x. You'll lose one of your critical numbers. You'll lose one of your solutions. So you do need to solve this by factoring out the greatest common factor. So we can factor out a 3x and then have x minus 2 equals 0. Setting each of those equal to 0, you would find that your critical numbers are x equals 0 and x equals 2. So that's step 1. You have found your critical numbers to be x equals 0 and x equals 2. All right. Once we know the critical numbers, step 2 is to evaluate the function. And remember that we had from -1 to +3 as our interval. So now we're going to evaluate the function at the two endpoints, as well as at all of your critical numbers. And I found that the best way to organize this information is just to make a chart. So I'm going to do that. I want to give myself just a little bit more space to write in. So I'm going to try to white out this area. And you are checking it in the original function. So x and f of x, not f prime. So you'll need your endpoint. I'll try to label that for you. You'll need your critical number, and you actually have 2 of them, and then your other endpoint that you'll be checking. So we'll need to check when x is -1. We'll need to check when x is 0. That's one of the critical numbers. And by the way, if your critical numbers are not in the interval, then you don't use them, but both of these are. and then 2 is in the interval, and finally 3. So we're going to substitute in. So that just means you're doing f of -1. I'll trust that you can substitute in -1 and get the answer. So that ends up being -4. You're going to do f of 0, and that turns out to be 0. You'll do f of 2. And again, remember you're plugging into the original function. This also is -4. And finally, you're doing f of 3, and that also turns out to be 0. That doesn't always happen, but it did happen in this one. And then step 3 is to state your maximum or minimum values. Now, I've run out of space down below. You should still have plenty. So I'm just going to make my conclusion up here. So for step number 3, your absolute minimum, and I'll just abbreviate here, your absolute minimum is the y value that we found. So that would be -4. So minimums and maximums are y values. But then you can say where it occurs. So it occurs at x equals, and it happened at 2 places, -1 and at x equals 2. So that's your absolute minimum. And then your absolute maximum. So the absolute max, and that will occur, or excuse me, that value is 0. So again, the y value, and that occurs at x equals 0 and at x equals 3. So sometimes it only happens at one of those x values, but there will be a highest and a lowest value guaranteed for each one of these. So at x equals 0 and then at x equals 3. All right, so you see your 3 steps. You do your derivative, you set your derivative equal to 0, or look for where it's undefined, and all of those x values will be critical numbers. Then you evaluate the function at the 2 endpoints and every critical number between those 2 endpoints. And finally, you make your conclusion based on your evaluation. Your lowest y value will be the absolute min, and your highest y value will be the absolute max. So I'll continue on with problem 6. And I have it on here once again because it involves an absolute value. And I just want to remind you about that process of finding the derivative. So step number 1, we're going to find the derivative of f of x, which equals the absolute value of x minus 1. So we'll use the limit definition. So f prime of, now actually we need to discuss what our c value. We want to use the x value that causes your absolute value portion to equal 0. So c will equal the number that causes the absolute value of x to equal 0. Well, in that case, c will equal 0. So we're going to look at f prime of 0. And in doing this, remember that would be the limit as x approaches 0 of f of x, which is the absolute value of x minus 1, minus f of c. So that means we're going to be plugging in 0. So the absolute value of 0 minus 1. And then all of that is over x minus c. So x minus 0. So once again, I got c equals 0 because I looked for what caused the inside of the absolute value to equal 0. All right, well, let's let's keep working on this. This would be the limit as x approaches 0 of, and if we evaluate there, we're going to get the absolute value of x minus 1 minus 0 and plus 1, because we'll have to distribute all over x. And that turns out to give us the limit as x approaches 0 of the absolute value of x over x. And if you will investigate that from the left and from the right, so if we do the limit as x approaches 0 from the left, removing the absolute value and using the negative x over x, that would be negative 1. And the limit as x approaches 0 from the right, we'd use the positive branch, so x over x. That would simplify to 1. We see that f prime of 0, so the limit does not exist, and therefore f prime of 0 is undefined, which means that x equals 0 is a critical number. So we did all of that work so that we could find our critical number to be x equals 0. So that's step 1. Step 2, as we did in the previous problem, is we're going to evaluate our original function at the endpoint. So let's consider what our interval is. Our interval is from -2 to 2, and our critical number is in that interval. So we have an endpoint of -2. We have a critical number of 0, and we have our other endpoint at 2. And we're going to evaluate f of x there. So f of -2, putting -2 in place of x, in the original function, you'll end up with 1. At f of 0, in the original function, you'll end up with -1. And plugging in 2 to the original function, you will end up with 1. So there's the evaluation, and then finally your conclusions. So step number 3, you have an absolute minimum. That absolute minimum value is -1, and that occurs at x equals 0. And then you have an absolute maximum, and that value is 1. And that occurs at 2 places, when x equals 2 and when x equals -2. And so you have your 2 examples that are determining absolute extrema on a closed interval, and then also where that occurs. So one more time, the absolute maximums and minimums are your y values, and then you state the x values where those occur. All right, this will help you out, I hope, with homework 27.